just the only analogy I'll give, I've only seen this once before in my life when I was in charge um, down at Fireman Past. I was a CTO, and we just digitized and indexed the 1911 census, which is the first census before the Second World War. And all those genealogy guys love that sort of thing. And it the uptake was so fast, it felt a bit like this. It was like shit, 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 shit.
Yeah.
We're going to buy servers.
Right. Okay. So we do
How we're
not.
going
I'm
to
pretty sure we don't have a scaling problem. So let me.
No, we've got. I think we just need to keep a cool head, but it's hard
Oh
to
god,
do.
it's so hard. It's like so many opportunities and units, and they're tempting, right? Because all of them are uh, like they're all valuable right now, but the temptation is to not finish the fabric and to take advantage of a half-assed
Right.
thing, right? I think that's the only real fatal move that you can make, which everyone around is screaming, take the money. But I'm like, if we can hold the line to deliver the fabric, then we can leverage, we can stand on that, we can pivot.
Yeah.
We've got a fulcrum. Okay,
Yeah.
so
We've got a fair few things to say about that, but shall we start recording
it's recording now.
if we
Do
have
you
a
want me
minute?
to restart the recording?
Cool. No, 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 no. What I
No.
was going to say is, uh, right now on the Fabric, um, a really shitty version would be the One-Eyed Man. Um, it would get eaten up, even if it's a bit shitty. But there are certain parts of it that we do need. We know what it's going to look like in the end, um, but we can go through that
All right.
in
Okay,
terms
well
of
the
what
the
I've been doing, and interesting to see what these guys have been saying as well.
yeah, the
See what the
crappiest the
overlap is.
crappiest possible version of the fabric is what I have been building. It has required
Excellent.
a certain amount of tuning just so that it's usable. So I was at the end of last week looking at doing an import of the customer data for the trucking guys that was going to take 13 hours to do a brand new import of all their customer data. That's not including transactional data, which is too
Mm.
long. And so I was able to set up Open Telemetry to monitor the activity of the cloud uh, based calls that were being made. You can see a couple of them here. I was able to implement tracing and caching and a nice little a few sleights of hand on the Fly.io infrastructure. And the result was I got the import down to 10 minutes and 47 seconds. That can be improved for 27,000 customers. That can be improved, but I don't think it's worth the effort just now. There's bigger fish to
What's
fry. Yeah.
what's I mean, import is one-off, but what's the stats for read writes or just normal usage? Because that's the thing that really matters.
Well, I can, as a browser, you can fire up and pull down that list of 27,000 customers in about 10 seconds, which I think I can optimize it to be around about 3 seconds. So that's a lot of little files, which is often torturous for any kind of system. But that can be, yeah, around about 3 seconds. Is that what you're asking?
Yeah, my view is 10 seconds is actually good enough.
Good enough, yeah.
Um, yeah, given everything else we need to do.
Yeah, that's right. That's right. That's right. So that's sort of where I'm drawing the line. Is I'm like, good enough is that's what we're running with because there's plenty of other problems. I was very pleased with that. I think that's an excellent result. There is no traditional database in it. It's just an S3 bucket. The consistency is very strong, and the transactional guarantees are amazing, actually, because they are per Git commit. So you can do arbitrarily large modifications, and then if that commit can pass without someone else having committed before you, then that's your transaction done, which is really quite liberating. Additionally, I can, in the browser, have very rapid access to all that data and all those commands like forking, merging, creating new repos, pulling from GitHub, and I assume pushing to GitHub, but I haven't tested it. And so the basic sort of shitty version that we're launching with is you're able to pull in things from GitHub so you can bring in existing work, push things out to GitHub so you can feel like you've got a safety backup, share and work collaboratively on these repositories with each other on our platform, analyze the history, all those types of things. That's how the model rolls. Yep.
So we'll come on to why I'm asking this, but it should be obvious. In terms of security guarantees, we're still using, the Fly.io, etc. security guarantees.
The security guarantees are Fly.io the Fly.io secrets management is the weak point of the system. Now, you are welcome to run your own deployment on Fly.io using our software, but if you want to get off Fly.io, that is another hurdle of work that we would have to do. You could run single server, no problem, but Fly.io provides the safety whereby we can scale beyond what I believe anyone can hit us with very rapidly and very cost effectively, very proportionately. Like if we get 100 times load, our cost will only be 100 times. It won't be like 1,000 times. Like it's a very, very granular, graceful growth curve that Fly.io provides us. That infrastructure is their value. That's why they're there. So, yeah. Yep.
Kind of drill down on why you're saying that the Fly.io is the weak spot in terms of security.
Sure.
So, well, what security, what audit chain of security guarantees do they require, or do they provide? Sorry.
You mean beyond those agreements that I showed you previously, where they will enter into a data processing legally binding data processing agreement with you?
Yes. So you're saying, because previously, the fact that they're willing to enter into an agreement is
Yep.
like golden.
Right.
But you said it was a weak spot, which is surprising because
It's a weak
when I
spot
looked
because
up it, I was thinking
it's someone else's computers. That's why it's a weak spot.
right.
They will promise hand on heart,
then
and they will sign legal documents to give you guarantees around that, but it's still someone else's computers. I think that War Fabric needs to be deployed on someone else's computers, but ultimately it needs to use confidential computing to allow us to have privacy guarantees about the workloads that we're running. We won't have that to start, and they won't be our computers that it's running on. And so long as we're open about that and light a path to which we can improve on that situation, that's going to just have to do for now, I think.
well, I think it's probably better than what we've got at the moment in War Fabric deployed, let's call it. um, uh, OPSEC is awful. So that would be a step up.
Right. Okay.
You and I know that is not enough, but it's a hell of a lot better than what they've got.
Yep. Okay.
Okay. All right. Good.
I
All
just
right.
realized I wasn't sharing the screen I was talking about, which is these traces, which give they show
Yep.
different latencies for different operations running on the cloud infrastructure. There are some oddities where occasionally a read from Tigris will take 3 times as long, like 670 milliseconds. It should be a lot faster than that. They should all be around about 250 millisecond tops, possibly faster. So there's a little bit of there's some oddities there. I think it's because Tigris is new and they're still figuring out their consistency guarantees. It is unideal, but in terms of the user experience, the user wouldn't, I don't believe, would notice that type of latency at all.
Yes. It's anything north of 15 seconds, you just hit refresh, and the problem with that is, of course, you start the entire thing again. So it's good enough again.
Yeah.
Obviously, it's not ideal.
Yeah.
Ideal is 2.5 seconds.
Yeah.
or
So
lower.
well, I reckon we can actually work at it and get it to instant, like sub 50 millisecond. But we don't the effort. This is not the round to be doing that effort.
No, I agree. I absolutely agree. It's
So
functionality over speed right now because we can foreshadow.
Yeah. So one of the
this
benefits
is going to be slow and it will only get faster.
Yeah, right. Like, it's not going to go slow. So one of the upsides is that it is the amount of data that it's already processing is quite extreme, quite incredible, I think. And that's due to the fact that it's an S3 style bucket, which means you can pull from it in parallel very heavily. And the get data structure, because of the fact that you have a commit that allows you to know the hash of all these arbitrarily large data sets, means that you can pull it in independently based on its hash. So the bucket model plus the Git model, they go really well together in terms of the parallelism that you can achieve and the sheer volumes of data that you can put in there by virtue of these basically unlimited size transactions that can be uploaded in parallel. But the weakness is some of the consistency guarantees are a little bit jittery or slow, but that's the only downside so far, and that will improve.
None of the applications that I've been working on is high number of users. So consistency guarantees are only really required when you got a high number of users.
Not true.
So
Consistency,
is there a way
that's not true. High consistency guarantees are required always because you don't know, like, you need to be able to deploy the next version and restart servers, so things are crashing all around you on purpose anyway. And so half open commits and all that, those are always a problem.
What you're saying. Even with one user.
Even with one user, you need that guarantee, or else you can get stuck halfway and it'll be mesmerizing as to why.
Yeah, and you lose confidence in it.
Yeah.
Okay. And so, sorry, can you rewind about 60 seconds about the guarantees that we have and what we don't have?
You mean for the correctness guarantees of the system?
Yes. Yeah.
there are no faults. There are no known faults in the correctness guarantees of the system under this design.
Okay.
And
Okay, that's good enough.
I don't know how to say that any nicer. That is what we paid for. That is what we paid for years, is to be able to say that one line. There are no known consistency faults
Yeah.
in our system. There was always, throughout the last several years, there was always known consistency faults that were like, well, don't know how to solve that. We got to just keep going. This design has no known consistency faults. Provided that
That is.
the guarantees that Tigris offers are upheld, which are very simple, then our system has no known consistency faults. And what that means is that you can supply a different kind of database, any kind of database that you want, so long as it can provide weekly consistent blob storage, which kind of any system does, including a hard drive. And I'll add that your storage can be faulty, so because the Git system has hashing built in, even if your blob storage is faulty, we'll detect it.
Mhm.
And the only atomic guarantee that we need is you need to be able to strongly consistently store 40 character long strings. And if you can consistently store 40 character long strings and blobs that are sloppy, you can run our system. I think that's a good design.
Mm-hmm.
So if you've got a Postgres database, fine. If you've got some disks sitting around and just, they're a little bit flaky, that's fine too. We'll take them.
And intermittent transmission, comms.
Comms is intermittent comms are only handled at the file level at the moment. So a failed retrieval will be retried 3 times and then it will halt on you. But we can modify that to be arbitrarily resumable. So when you start downloading a file, you can always resume wherever you left off. But again, that's like a nice to have. I've just gone for the easy thing here.
Yeah, that's. I hate using that word, but backlog. Yeah.
We need to get the backlog
now.
system up on this system to then make it perfect, as opposed to, this is just enough to be usable to the point where people with ADHD don't just close the tab. It's powerful enough that it should be enticing. Like, it's basically saying, hey, I can store as much data as you like near instantly forever with, hash-based guarantees and all this other stuff. And it, yeah.
Sorry, I'm jumping around a bit here.
That's fine.
But you
totally fine.
follow my train of thought. On provenance, I assume that now we're talking at the kind of storage and execution level here.
Oh yeah.
I assume that the hash.
The execution is not repeatable at the moment. So that as soon as I can catch a break, I will implement that. The execution layer probably took about. I spent about 2, maybe 3 years on that, from the period of 2020 to 2023 was actually figuring out the execution layer. I paused the execution layer to deliver this data layer because, we spotted this ability in the distance. To put the execution layer into this, I feel is not trivial, but very short, because all the hard work's been done already, I think.
Okay. well, if we're getting a stack rank, uh, uh, re-executing in order to prove, not strictly necessary for the stuff that um, the real world stuff.
Yeah.
It's just that this guy did this, then is um, assumed to be trusted. Now,
Yeah.
re-execution of
It's
is
a
fine.
little. It can be a little bit stronger than that because
Uh-huh.
whilst I haven't implemented it in this version, I think it is merely a couple of hours work to implement signatures on the Git commits so that you can at least know that it was our servers that did the commit. And whilst you may not be able to fully replay the execution, although you might be, at least you will know that it ran on our servers, which is different to not
That
having to
that
not
is
knowing that at all.
e- e- exactly. So we can talk at the end about stack rank of features, but that one's quite important. In that for the trust in the system, it's not necessary, or not necessarily necessary to replay. It's necessary to know that it's not being diverted to, some other server that you don't trust or
Correct.
you don't have security guarantees. That's
Yeah.
more than sufficient. But that part
Yeah.
of knowing where it goes is really important.
Okay. So that's what we got with.
Basically, where's the data? Where's the data? Yeah.
Yep. So we have that. Um,
Sorry. Sorry to interrupt again.
yeah.
Do we have that, or is that 2 or 3 hours
Oh, sorry. Yeah, it's 2 or
hence
3
of work?
hours to add signatures in there. I haven't done it
Right.
now
Gotcha.
because there's no way for you to check that until I implement the push to GitHub function. Because when I implement
Hmm.
push to GitHub, then you'll start to see. When I implement push to GitHub, that's when you will start to see the verified commits thing pop up. So just give me a second. Do you know what do you know what I'm talking about when I say verified commits?
Yeah. 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 I do. Yeah. 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 Can I just check? Although GitHub is widely used, a private Git instance would be identical or not.
Well, yeah, you could verify it yourself, but what I'm looking for, what I was hoping to show you actually, which I sort of can't for whatever reason, is that you get this verified stamp next to your name, which is where because Git includes a signature mechanism for being able to sign it, it's just one extra level of guarantee that the server did indeed process your. It was our server that processed your data.
Okay. All right. So, um, correct me if I'm wrong, but there could be a piece of tin somewhere um, that hosted a Git instance, and um, given what you were saying, I understand that it should be possible just to use that instead of GitHub cloudy thing,
Yeah.
but you wouldn't. You would then be restricted by the tin that you're running on.
You can run our software on a standalone piece of tin, but your performance will be
Hmm.
limited to that tin, as will your resilience, and your global
Yeah,
distribution
yeah,
footprint will suffer.
yeah, 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 yeah.
I would also
And
have
there's no
to
way around that because tin is tin. Tin
tin
is
is
tin.
tin. I would have to make a stand-in a stand-in for Tigris. I kind of know I could probably knock that up in a couple of hours, but it would be like a database, like a SQLite database
Okay.
that stood in for the consistency guarantees of Tigris. And then I guess
All
I'd
right.
probably just
Well,
use the disk for the blobs.
stand fast on this. When I go into my piece, I don't know yet how much they'll care about whether it's a piece of tin or
Yeah,
whether
it's
GitHub
kind of
is
like
trusted.
right. It's
Don't
a
know
bit
yet.
of a
Don't know yet.
it's a much of a muchness, right? It's like, well, we got to get going, guys, and then here's this pipeline of jobs to do. There's people dying. There's all this other stuff. Is running on our own tin the most important thing of all these things? You decide, right? And that's
Well,
the position we got to get
this
to.
is this is you'll hear when I give my debrief.
Mm,
There's a lot of kind of soft skills about perfect
yeah,
versus
yeah, yeah,
fuck's sake, we're
yeah,
really imperfect
yeah.
right now.
So I guess overall, look, I'm feeling really good about the quality of the code, and I am relieved that the design has worked. It has survived in single node, cloud deployment, and in browser. And those models have all stood up performance wise, consistency wise. It's easy to program with. It's easy to think about because it just follows Git. It can handle large numbers of files. It can handle small files.
Mhm.
It's I think it's really good, dude. I think that this is the thing to depend upon. Like, I think we can take this one home. Like, this is it. This model works
I
great.
think so. I'm looking at your diagram and the ingest from email and various other um, sources.
Okay, I'll
I
jump across
assume
to
that's
that now
just a
then.
matter of clagging together. Yeah, please.
All right. So
Yeah, this one. So manual upload. Um, I assume that is a
all right.
Git-like
So yeah,
process,
just
as
a
in.
couple of steps back. Like, this nuts and bolts stuff with the data structure under the hood is
Mhm.
then, like, as soon as we have that, we can just do, like, all the things we can do on top of it. I think there'll probably be some tuning here and there for performance, but other than that, it's like, well, we can probably do anything we've talked about on top of that fabric. Now, the diagram here is about a new a realization that was brought to me, really, about a type of work that we hadn't thought about before, because we'd always pictured the
Mhm.
work that the Dreamcatcher did as it was all novel. The problems were always novel, and the work of the Dreamcatcher was to solve the novel problems, right?
Yep.
Yeah. But there's another type of job that is actually probably more common, and it's a production line of work. And so, some background on this story
Mhm.
is that there is a very large multi-billion-dollar railway project happening, and the core realization that was explained to me, that I didn't know this, but now that I heard it, it's one of those things that you're like, oh my god, that's true everywhere for all time, is that the people that build things are not the people that stick around and maintain them. And why that's important, especially in the age of highly digital design, is that it's not just the handover of the physical asset anymore, it's the handover of all the data that went into constructing it, all the invoicing, the as-built CAD models, the faults, the fixes, the remedies, all this data, like photographs, emails, like all that stuff gets kind of dumped like a wheelbarrow into the receivers on their office floor, basically. And it's like, so the person I was meeting with explained to me that if the local councils would specify that their procurement included data formats, they could solve this problem at source, but no one seems to want to do that. And it may just not be possible because there's an infection of the data occurring, because you've got your primary contractor, but that contractor contracts out to subcontractors who ultimately, somewhere down the line, there's some one-man band electrician that ends up getting a work order to do some stuff. He's not going to supply you the data in the data format that the government department specified in the quote. He just isn't. And so what you get is, by the time you get to handover, the data is already impossibly degraded, and plus the primary contractor kind of just did whatever was easy for them, and no one wanted to pay the extra money to fit the compliant data standard. And so here's your USB stick, your couple of hard drives, and a Dropbox folder with all your stuff. See you later. So that's basically the situation, and what you end up with is these job queues. Now, this particular job it's only just become aware to the council that they are receiving something like 50,000 assets and the digital files that go with them when they take possession of the finished work of this project. And they're going to receive these files within the next year, and they don't know how to handle the ingestion of all that data and the translation to their standard formats and the input into their management systems of all that data. And so, pardon me if this is a little bit of a long-winded way to get to it, but there's a bunch of work out there that is job queue work, where there's like a big stack swaying in the breeze of jobs, where the jobs are all similar but different enough that you can't just write a program to do them. And the key example given was that down in another city in New Zealand, there's a project that's been going on for ingesting some, I think it was some water infrastructure assets, where the ingestion process still has 18 months left to go, and it's being done manually by people who are a team of people, is opening up these files, modifying the files, saving them in different formats, and then putting them into the council's management systems. And that's the state we're in.
The reason I was smiling there, although in VR nobody can hear you smile
or cry,
is you're absolutely right. We've been talking about this as an innovation machine, but the execution machine is actually more important. I'm getting a lot of the opportunities that have come to our plate all require some kind of, how are we going to actually use this thing?
Right. Yeah, and I think that's what we've been missing, right? Because from this model is the perfect place to put agents in, because what you do, if I can just give a quick overview of the design here, just to make sure we're interpreting the picture the same way. The The idea is that you have a job queue with human workers that all run through the same fabric. We all
Mhm.
observe the work that's being done and look for similarities and look and test AI agents that can do some of those problems, any of those problems. When we find
Mhm.
them, then we can deploy an agent that adds to the workforce that begins processing jobs. The innovation machine is there to find how to write applications or how to write new agents to consume that queue quicker or with higher quality. As well, the Dreamcatcher network can be used for the recruitment and retainment of the talent um, that does the manual processing when no alternative exists, while at the same time not teaching the machine like some kind of an intelligence, but improving it little bit by little bit with small feedback after small feedback, patch after patch. And that's what makes the system valuable, is that it starts to grow in, it just has a broader and broader bucket of tricks and techniques that it can deploy.
Right. And just to be sure, we're not talking about running uh, uh, or producing a new LLM. We're just those techniques exist as static files that are discovered by existing models, and then the existing models will, over time, get better and better at
Yeah, that's right.
finding
That's right.
those.
That's right. And so the
Yeah.
job rate, the rate at which you can process the jobs starts to go up very fast. Now each time you process the jobs, you generate problems, and the innovation machine deals with solving those problems, but the net effect is the rate of job throughput that's happening under the hood. So we'd only ever thought about the stux per minute, but the integral of stux per minute is jobs per minute. Like,
Jobs executed. So,
yeah,
for example, let
jobs done
me
per minute.
reflect back to make sure I understand this. So, a very simple thing: you get in. Um, uh, let's just take email as an example. So, you're getting a lot of email, or let's use Signal. So, Signal, lots of text. Most of it is noise, nothing to do with you. Um, that's ingested. Uh, each the job queue itself can be pruned because you can get rid of the
Yeah,
hey, yeah,
yeah, yeah,
sort of
yeah. There's
useless
curation.
stuff.
There's curation of the job queue, of course. Yeah,
Yeah. And then it would go, right, okay, so um, uh, worker A
yeah,
um, goes to the system and goes, hey, what should I be working on? The AI agent not only has curated the incoming messages that
right,
might have been to a group call,
right.
a group stack of messages, and saying, you were mentioned in this one, or this is the thing that you're working on, and so
Yep,
pay attention to that. So immediately that collapses, 100 messages right down
yep,
to, like 10 that might be of interest. But then also the AI agent can point you to saying, you actually asked for this and someone's responded, and that has to do with the job that you're working on. Um, so it's the improvement of the signal to noise ratio in execution. So we're not talking about innovation here. We're talking about just reducing that signal to noise. What should you be working on? And you know, um,
I
even there's
think that
another piece.
I think that what you're talking about is a useful way to use the system, but I don't feel like it's hitting the essence of this new point that I'm trying to raise. Um,
Hmm.
how can we best go about understanding here. Could I give you the example, the specific example that this picture was drawn for?
Yes.
Yep. Okay, so here we have, and I'll just try to keep the names anonymous. Here we have contractors that built a massive railway tunnel network, including 50,000 pieces of building information management data and emails and manual files and photos and all that. They just dump it in a bucket. We have a bucket. Our bucket can handle all that stuff. So let's call it like maybe a couple of terabyte worth of files.
Mm-hmm.
So I am proud of that about our bucket. Actually, our bucket is pretty much as big as you can buy. That's how big our bucket is.
It is wide and generous.
Yeah. And thanks to Fly.io scaling, it's also like incredibly elastic. So even the processing, not just the data storage, but the processing of that data is effortlessly and locally scalable, which I think is a very, very good thing. So contractor dumps a bucket. This whole system is working within the council. The council is the one that's going to manage these assets once they've been ingested and scrutinized and all that. There are some simple processes to start with. On day one, it's just simply a very lightweight LLM or no LLM that turns the ingestion of each piece of data into a job on the job queue. The job queue is observed to be swaying in the breeze, but at least we know that that is the complete job queue. We then have a job dispatch, which at first is a human passing jobs out to some other humans. Let's say that there's 10 of them. They sit in an office in downtown Auckland, and they one by one look at the files, process the files, and then they store them into a gold data bucket, which is the standard format data that's been approved. Okay, so that's version 1 of the platform. No AI or very little AI, just machinery.
That sounds very AI-able, though.
That's the point. That's the point.
Just an aside. Yeah. I was just sorry. Go on. Yeah.
Okay. Now the treasury of the project looks at the size of the queue, looks at the processing rate of the queue, and says, "We got a problem. We need some more human workers. We need an AI agent that can decrease this queue for in any way, or we need some applications that can decrease this queue." Now, first off the bat comes Mr. Maxwell with some prompting skills, makes an AI agent that can handle 1 in 100, 1% of these jobs can be handled by this agent. So it passes its tests, it passes its evals, and now it is a worker alongside the humans that is able to draw down jobs from the queue, process them, possibly pass them to QA, but ultimately put them back into the bucket of gold standard data. This continues somewhat. The AI agent is improved. Treasury looks and says, "I like those AI agents," unlocks a few more pennies, puts out a bit more escrow. Now there's some even more prompting engineers are incentivized to create agents. The point I'm trying to make with this model is that the human workstation, where the human does the work, is interchangeable with a new agent coming in. And it's not the scenario you described was helping the worker work better. Sure, that's part of it. I'm sure that they can make more tools, but the essence that I'm trying to highlight here is a system where agents are pluggable in place of humans, and where the agents are not known ahead of time. Like the system starts with no agents, then it has 1 agent, then it has 10 agents, then it has 100, and then the job queue is gone. And that's the system.
Okay, pause. That makes sense because we're talking about a steady state model here where um, you're adding AIs or removing AIs, adding workers or removing workers, but you're getting to steady state based on what any particular LLM can do based on proving itself through the system of tests.
Yep.
And so it might be the case that a particular system, for example, being a steady state system, might end up with all AI agents until something unusual comes up. And it's like, we need a worker.
Right. The unusualness is the thing I want to drill in on. The unusualness is that's the bit that's handled by the Dreamcatcher, because the idea is that work proceeds as before, but every time there's a job that gets done, there's always something a little bit wrong. Sometimes it's a big bit wrong, and those are the things that the Dreamcatcher is used for. It's not the Dreamcatcher doing the work directly, it's just the exceptions and the improvement. And the whole point, or what I think is the beauty of this model, is that it's future-proofed in so far as by not saying what the agents are or what the apps are, by simply defining the data format and the workflow, it's possible to say that you can adapt to any job in the future because you can plug in a human or an agent or whatever comes next after AI. I don't know.
Oh, yes, but also we got two. So in this QA worker specialist AI agent application layer you've got there, we're not specifying who does what.
That's right.
Based on a job, it might become at one point all AI agents, and then it's like let's solve world peace, and then it becomes all specialists. So it's veers and hongs between the QA worker. I think is slightly odd there because a worker. Okay, yeah, I'll think about that one. But basically, it's people, AI agents, or applications, and it's like, who does the job go to?
Yeah.
The job dispatch decides, okay, well, how about we send out this job to a specialist, a worker, and an AI, and if we've got a QA for a well-defined job, um, then we can decide whether, let's say we've got 1,000 jobs that are the same again and again and again. Let's
Buddy, are
decide
you?
if
I
this
feel like
needs a
are you
specialist.
thinking through this in your head just out loud?
Sorry, I'm doing that. Sorry, that's a habit of mine. I'm just thinking. I'm thinking aloud.
Okay.
Yes. But
Do you want to just take some
essentially,
time and have a think?
yes. I agree. This is a steady state model that on job dispatch, that's the key thing on this one. But dispatching to more than one in parallel and then
No, no,
having
no.
a
I think you're.
QA.
I think you might be falling in the trap of trying to design a system. Like the job dispatch is part of the system to be solved as well. It's not. It's just a pluggable point where
All right, yeah.
you can plug in a job dispatch module or a job dispatch
It
person
is a
or
piece
an
of work to be
agent.
done.
Yeah, and that's the
Yeah,
thing I'm
it's
trying
a
to
piece of
get
work to
to,
be done.
right? And so if we can get this system installed in a local council, it should be very cheap to get it installed because it's really just a database system with an interface for doing job dispatch. And then we're saying that, as a revenue stream, we'll take a cut of the humans that we find, so we can provide a like a vetted pool of people out of like Ukraine or Manila or wherever, and we'd just take a cut on the labor management because we save the council recruiting fees and office costs and all these other things. But also, we're already getting baseline pricing for how to value the work of the AI agents. And so the system becomes very light to install in an enterprise. And then all of these enterprises just have their own independent installations, and we just try and connect up as best we can to supply workers and AI and agents to these little sweatshops that are running in all these different companies.
I agree. Can I, very modestly, because I'm just thinking this through, QA worker,
Yep.
I would argue, really should be a add remove workers, because
No.
they're
No.
saying, is this good enough? Why is a QA worker different from a worker? Just tasked differently.
It's just tasked differently.
So a QA worker is the same as a worker, except
Yeah.
with a different task.
It's
A
just, well,
worker and a specialist.
okay, so with
How
limited
how are
time
they
and
different?
limited icons, okay, these little icons are supposed to represent the
Yeah,
fact
okay.
that you can arrange your job workflow, your processing workflow, arbitrarily with as much complexity or simplicity as you want. And you can set up QA processes, you can have no QA and just YOLO it. It's entirely up to you.
Okay, yeah, I'm probably starting to hallucinate here, but I can see how to simplify this. But yes, for that general case, yeah, sure, this works.
All right.
Um,
Now,
okay,
again, I
so let
just want
me
to check
look
that
at this.
what I'm trying to promote here is coming across clearly. I'm trying to promote that we've overlooked a type of work that is very useful for the Dreamcatcher, which is batch processing or job processing work, where the jobs themselves are not something we're interested in, but the creation of solutions to accelerate that processing is what we're interested in.
Yes. So where does it get kicked out into the stuck loop?
That's sort of that's not shown. That is implied, like that's across the whole diagram, really. The stuck loop is observing.
Okay, so there's like a
The marketplace, I suppose, is
big
the
arrow.
closest place to it.
Yeah. So in this QA worker, specialist, etc. level,
Yeah.
can't be it, the job that's been dispatched can't be done. It gets kicked off to another diagram, which is the stuck loop.
Um it would possibly, but in general all jobs can be done by the humans that are there. It's not it's not the ingenuity required, it's the time it takes for a human. That, I think, is the key difference I'm trying to get at here. This job queue, any one job, any human can do. It's the volume that's the problem. It only becomes a problem, like if you're like, oh, that's just 5 minutes. I open this file, I do this and I do that. Yeah. Do that 50,000 times and now you've got a problem.
Uh, I'm not going to go into this rabbit hole because I don't think it's needed, because I think this is a good diagram. But I disagree with what you just said in that I can easily think of a job that goes into the job queue, which is currently impossible and therefore is stuck.
No, yeah, I think
But then feeds
I think you're
back
thinking
in.
about this whole thing wrong, because this is not for general problems. This is not a pipeline that's open to the whole public for anyone to see and come and be part of. These are closed pipelines with very restricted, limited jobs to do. sure, you might get a job. You if you're being difficult, you could put a job in that can't be done by a human. But the majority, or the point of the system I'm trying to illustrate, is that there are internal problems to councils and to other enterprises that often end up with this shock load of data ingestion that it needs a way to be rapidly solved, and they don't know it ahead of time. The problems are novel as they work through it. They're kind of boring, and it's the size of the data that makes it a problem for them, not the difficulty.
Yeah, which I agree with that. Um, and this is why I'm saying I don't want to get into solutioneering on this one, but if there is a real stuck uh, that the available set of workers, specialists, and AI agents can't do, then um, uh, that would stop a major, for example, real project in its tracks. I'll give you
Wait,
if you
what's
if
the point?
forgive
What's the
forgive
point?
me
What do
for
you, what's the
giving you
point? No, I don't. What's the point? What are you trying to get at?
the point being is this diagram is correct. I follow it and it's good.
Then
I
that's
think
sufficient, right? Like,
it
there's
could
not.
be and it that's sufficient for execution. Yep. I think it could be enhanced by some pointer to the stuck loop. Um, but that's not necessary for execution. This is an execution diagram.
Yep, it's about execution.
Yeah. Whereas innovation is about not execution. It's finding how to sharpen the saw instead of
Yeah,
getting more people with saws.
right. Meta execution. It's like
Yeah.
the business of
Yeah.
execution.
Yeah. So I it's a good diagram. And you're absolutely right. We haven't actually talked that much about execution. We've been talking about
No,
innovation
no, that's
a
right. That's
lot.
right. That's really what I was trying to get at, is that we haven't considered that
Yeah.
we can use the fabric to set up a job queue in a way that does execution, because execution is the problem that people present with. Innovation is the solution that they don't know how to ask for, but execution is the problem that
Yeah.
that's what they present with. They're like, we've got an execution problem, and you're like, no, actually you have an innovation problem, but no one wants to hear that. That doesn't help them.
Right. And it's almost like if you on the add remove workers, that assumes that there is a stack of available workers. And on the execution level, that would be static. Um, because a worker effectively is an agent that does a piece of work. If an agent doesn't exist to do a piece of work, which is the reciprocal of stuck, then there's another diagram. Let's go and generate that agent. Now, maybe it's an AI agent, maybe it's finding a specialist.
Yeah, but that diagram
Or whatever. And then you
is the Dreamcatcher diagram, and so we basically that's the
exactly,
Dreamcatcher
yeah, yeah,
diagram,
yeah, yeah.
right?
So
And we need to not give
yeah,
the
I guess
Dreamcatcher
now.
diagram.
So again, sorry.
We need to not give the
Sorry, I missed that
Dreamcatcher
last bit. Sorry.
diagram, because nobody wants to buy the Dreamcatcher, but people definitely want to buy the job processor.
I agree. There seems to be two layers here, isn't there?
Yeah, that's what I was
And
trying to. I want to keep them separate on purpose, because this bottom layer sells.
yeah,
The top layer not so much, but
that yeah. Sorry to interrupt there. But the experience I've had with trying to sell a Dreamcatcher is it's a confuser.
yeah, it
Um,
confuses people.
someone wants something done, and you go, da, 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 and say, oh, how about, there's a marketplace for ideas, and they go, huh?
Yeah, it was one level
What's that
higher.
about?
Like, it's the first derivative of this thing is is actual ground speed, but the first derivative is innovation. Like,
Yes.
sorry, I don't
And
know how to.
then no. I think we're talking this well, on my side of the fence. I think we're in sync. Um, if you remember, oh God, 5 months ago, I think something like that. There was a stack diagram where we we kind of assumed that it would just be used, but this is now defined. And then you had the innovation layer, and then you had the layer that improved the innovation layer.
Yeah,
But in terms of execution, if we were to isolate this, then this diagram makes sense to me.
right.
Seems complete.
Good. Good.
Or seems correct, but not complete, as in we've got those other layers of innovation and then
Wasn't aiming
improving
for
how to
complete.
innovate.
Was simply aiming to
Yeah.
show that there's a revenue opportunity here that is not pure innovation. It's an execution layer that can bring opportunities, problems, and revenue to the innovation layer. That's the point of this diagram, because as it turns out, this problem is common to almost all of the councils in New Zealand, for one, several of the councils in Dubai, and I would go so far as to say that every council on earth has this problem.
Well, interesting enough, this also is in my discussions on War Fabric. This diagram you would accept. As soon as I step into the second derivative, then it starts to get woo.
Yeah, and
having
maybe we
elaborated
should
the third one.
we should package it like that, where we're like, here's the ground, here's the base, and then it's not even like, I mean, I don't really think much about how silicon oxide affects my life, or how tantalum doping matters here, there, and everywhere, right? Like,
Exactly.
I don't like. It was a
Yeah.
surprise to me to learn that the ultraviolet light that produces the GPUs that basically all my life runs on are created by vaporizing tin, which happens to emit a very brief but ultra highly energetic burst of UV light, which is used to use the photo mask to make the chip. I didn't know that, right?
Oh, is that how the?
You didn't know that either, right? And
Is
yet,
that how the? Yeah.
yeah, that's how it works. And
It's
we didn't.
abstraction. Yeah, it's abstraction layers, isn't it?
Yeah, and
You
so
don't really
there's a
care.
bunch of people that are working night and day to deal with that layer, so that we don't even have to think about it. It's the same here.
Right.
We gotta
Right.
separate our message out, where we're like, this is the kinetic, on the ground, in motion. This is why it's good for you. Everyone understands that. Animals understand that. This is the physical level. One level up is the Dreamcatcher, which is the level that we've been working in for years now. It is the most valuable and important layer, but everyone at the worker layer kind of doesn't care. They're welcome to care. They don't have to care. They're like, where did these inventions come from? Why does a hot dog cost $1? How come my car can drive to the other city without stopping? Like, no one asks those questions.
Nobody thinks about where the power comes from when you plug an electricity plug into the socket.
That's right. That's right. And that's how we got to.
Really
That's
interesting. Really interesting.
fundamentally, that's how we got to package our systems, because we've been fighting for a number of years with mixed messages. I am developing a physical storage layer. On top of that is a computational layer. And then on top of that is an innovation layer, which sits alongside a bunch of applications that are built on top of it. We got to stop trying to sell the Dreamcatcher. No one cares. We sell what it can do for them: the physical execution, the job processing, the database, the computation under duress. the stability in a time of chaos. That system, that's what they care about. The Dreamcatcher is what we want. We don't need to even talk about it with other people, really. We just deliver using it, and a few people will get it, and that's fine. That is, in fact, the balance of society. If you cut the strata of what makes people up between the thinkers and the doers, it's mostly doers.
I think you're absolutely right. And actually, in the conversations I've been having, not just with Warfabric, but with others, um, whenever I introduce any kind of Dreamcatcher concept, it's okay, right, okay, but I need this thing done. They're looking for outcomes.
Yep.
Which is, jobs in, outcomes out.
Yep. 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 They wanna
Um,
layer
yeah,
one.
this is a good way of.
Yeah, if we call that, well, maybe we should
Yeah,
call it layers, right? Like layer one is the doing stuff layer. That's kind of what they want to see moving. One level up
yeah, and
is the thinking layer. They don't really care about the thinking. We'll do the thinking. They'll buy the thinking.
yeah, yeah, and they'll just be, you know, delighted that there's an extra AI agent popped up from somewhere. Who
Yeah.
knows?
Magic
That came
tada
from.
woohoo.
And your job queue suddenly gets shorter.
Yeah, man, your dashboard on the wall goes from 18 months to like 9 months because this new agent turned up on the scene and you're like, oh, that's happy days. I might be done soon.
Yeah. 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 Why do I still have a niggle at the back of my head about having a QA worker? Ignore that for now. I'll think about that. I don't have an answer about why that's niggling. Worker specialist AI agent application makes sense. QA sounds.
Yeah, I mean, look, time is precious, and I chucked this together in,
Yeah.
2.5 hours to write that document and make this image. Without the help of AI tooling, this would never have happened. Like, like that's the speed at which you can do these things now.
Yeah.
So yeah, if you get a chance, I'd recommend having a look at that document. I thought it was a good summary of what's going on.
Yeah. Okay. So right. Cognizant of time.
Oh, send it
Yes.
off to, if you wouldn't mind sending it off to Marla as well, because I think that it's the kind of thing she would like to. It's the kind of problem that every consultant has. Not that she's a consultant. I meant that she deals in circles where this problem will be common. You could probably only take a couple of drinks to end up talking about this problem.
Yes, absolutely, I will. I think she will. Interested enough, probably get it faster than I have on this call because she's not thinking about the other parts. She's just thinking about.
No one else thinks about those other parts,
done.
actually. Like, people get this level.
Yeah.
Like, when I was drawing this diagram on the board in our meeting, it was the most effortless explanation I've ever had to do. Like, it kind of just fell out.
It seems very obvious because, because we've been working on a different problem, but everyone else has got their own problems.
Yeah. All right.
And
I think we've kicked this one enough. Shall I close out this recording?
Yeah. No, it's yeah, sure.
Yep. So final status: the fabric is currently having a UI attached to it. I'm connecting up the graphics component to the data component, which is already loading in the browser, and at that point, we have a deployed system that will begin user testing. it'll be any day now. So that's where we're at with that. And then
Brilliant.
once we have
Right.
that system deployed, then I'll make you a version that can be used for Warfabric, and we can do some initial testing to see what that user interface needs to be like, how the repositories need to be organized and structured to work.
Yes, which should be really it should be down to them to decide.
No, we should come with our version, and then they can give us feedback on that. If you give people a blank slate, you get stupid shit back.
Yeah, sure. I mean, I could probably give a start for 10.
Yeah,
The point
starter
being,
for
it's
10.
not baked in.
Starter for 10, nothing's
Yeah.
baked in. The only thing baked in is the Git structure, which covers kind of everything anyway. So if you can't do
Yeah.
what you want to do using
Okay.
files, I don't know what you're trying to do. I haven't heard your problem yet.
Everything comes down to files.
Mm.
It comes down to files because there's two types of information, isn't there? There's static data based on a timestamp. We thought this or we did this at this point, and then there's dynamic noise, which is how do we produce static data.
So
That
just to keep in mind, there is another layer that needs to be built onto Artifact at some point in the future, which is the real-time layer. And that would be the thing that would be used for sensor transmission, drone piloting, telephone calls, video, all those kinds of things. The Git model doesn't work well for streaming data, and so that's why it needs to be a separate undertaking. That's it.
Sure, but oh, it's gone. You've gone black screen. If you can bring the thing up. I mean, streaming data on the execution.
Streaming data on the execution layer is very, very useful because that is smart cities. So instead of this static data that is in the past, you would start putting in sensor data for IoT devices and other such things. And then the job dispatch is, again, a combination of humans, AI agents, and apps that then, instead of just egress into effectively file storage services, it can do things like trigger switches or pumps or
Right. Yeah, exactly. So
you know,
a job can be, well, let's take streaming, and it goes to an application. A job can be immediately dispatched to an application that deals with the streaming data that, say, saves the video onto Go data.
Yeah.
It doesn't break anything here. Same model.
Same model, different implementation.
Yeah, exactly.
So yeah, just keep.
Okay.
I guess
All
just
right.
keep that in mind.
Good.
Now, last thing before I'm done. That's for another time. That's for another time. Did you hear about the new models today?
Today? No. What's happened today?
Today, GPT 4.1 came out, and there's a couple of disturbing things that I want to talk to you about. So 4.5 is maybe my favorite model of all time. I may just love that model, but 4.1 outperforms it, apparently. 4.1 is a developer-only model, so not available in ChatGPT.
Okay. All right. Okay. Yeah. Okay.
It scores amazing scores. Like it outpaces O1 High in coding, for example, and it's a non-reasoning model. The context window is now 1 million tokens. They've released a new version called Nano. So there's 4.1, 4.1 Mini, and 4.1 Nano, which is so cheap that it costs about 12 cents for 1 million tokens.
1 million tokens is easy enough to take in a reasonably sized repo.
Well, here's the problem. It's also enough to take in all the customer records of the CRM app. And so I'm starting to wonder if that thing we glimpsed many moons ago was like, if there was no app and it was all context, if there was no database and it was just all context, is that maybe an easier way or a better way to build an app where it's just all sitting in the mind of the bot? So again, with the improvements, they've greatly improved the needle in a haystack capabilities of the system. So having 1 million tokens and being able to spot a needle in a haystack, it seems like they've kind of nailed it. So this was like, yeah, sure.
It could well be. Your thought that everything exists, instead of bringing in context, essentially you've got an instance that
is context,
embodies the context.
There's no separation between. There's no out of context. There's no yeah. Everything's context, and then at that point the complexity of the database system just completely collapses. It's like, sorry, what is this thing again?
Well, yes, it's
so. Oh God, I'm sorry. I keep on talking about the screen that I'm not sharing. My bad.
No, you are sharing.
You can see the pink squares.
Well, they're blue to me, but
okay,
I see,
well, let's not split hairs.
Yeah.
So basically, this is the needle in a haystack accuracy. On the vertical column is the depth of the needle, like how well hidden the needle is, and on the right is the context window size all the way up to 1 million. There is not a single failure at any point within this graph at no depth.
Oh, I thought that was a render. I thought that was a render problem. I was expecting to see.
I know, right? It looks like an error, but they have got it so that the needle is successfully retrieved at all context sizes, at all needle depths. And what that means, practically speaking, is that you can be having a turn-based conversation and go, what was the third thing I said to you? And it will get it right now.
But this, they must have, well, they've restricted it to code, right?
The needles? You mean, the access? The access is API?
4.1.
It's only API.
No. As in, the training set is constrained to code problems,
or is no, absolutely not. No, this is a general purpose model.
I could dump in the works of Shakespeare and say, who's Rosalind?
Yep, that's right. That's right. So needle in a haystack, incredibly improved. Prompting has changed, so you will need to. There's a new prompt guide that's out that you may wish to keep up to date with. that is to say that negative instructions, like saying don't do this, it no longer requires, according to them, the prompt amplification techniques that were being used in the past, like capitals and reiterating and all that.
Yep. Okay.
Step-by-step instructions are pretty good. Yeah, so basically all-round better behavior out of this model.
Right.
But this context window, it's starting to feel to me like we're almost on the verge of saying, well, the whole app is now in context. Now what?
Yeah. I mean, I think it was about 2 weeks ago. We were talking about the next drop coming. I didn't notice it was overnight. I'm going to read this. This is going to be, I think, I'm going to do a deep dive and see what this
Yeah,
means.
this is a good
in
one.
terms
This
of,
is a good one. Sadly, they're going to
Yes.
be deprecating 4.5 because apparently it just cost too much to run. That was what the experiment was. It's like if they just gave an obscene amount of compute, what could they get? It came out pretty good, I think.
They're the versioning numbers all over the place.
I know.
I was curious about the versioning.
I think it's because like these runs, like I was watching the podcast about how the 4.5 model was trained, and that started about 2 years ago. So you can imagine the model numbers getting a bit screwed up when you've got
So
one.
that's chronological, but then one might take
Yeah,
longer, but
yeah,
a
they
little
come
bit
out. They
better
come out in
after.
a different order than they start,
I
and so
see.
you gotta name them when you start because they're such a big effort. But then
Yeah.
they arrive in different orders.
Curious. I never knew that. That does kind of make sense, actually. Yeah.
Yeah. But
Okay.
yeah, look at this pricing, right? A million input tokens, 10 cents. And if you cache it, it's like a quarter of that, 2 cents for cached input. So you could have the whole app and each call you make to the entire app is 2 cents and then 40 cents
And
for the answer.
how does batch oh, there it is there. These models are available
Yeah,
in
and they're
batch.
fine
Okay.
tunable. And fine
With
tunable.
half price. Half price. Huh, bloody hell.
Yeah, but they're
Okay.
kind of like
Well, here we go again. Here we go
I
again.
know, right? Here we go again. So there's still a few
Right.
that the bigger models outperform on. Yeah, but that's the deal.
Okay. All right. I'll look at this.
So what to do? I mean, this is just I'm
Okay.
like, well, still, I mean, we're not in this game, right? Like this is a nation-sized game. We just have to respond.
Yeah. Yep, absolutely. Right. So, are we still recording or no?
Yeah, we're still recording. You want me
You
to
don't
stop?
have to stop. Yeah. Okay. No.